Okay, in this video I'm going to continue on with exercise 5C of the book Fundamental Applied Mathematics. We're on page number 140 and the question is 7. Now this question is similar in nature to questions number 2, 4 and 6. I did number 2 in a lot of detail, and question 6 I had a similar, a scenario exactly the same as we had here, and I solved everything in terms of the x prime y prime plane. So everything was in this axis here, or this plane, and I even resolved these vectors here in terms of the x prime y prime plane. And I'm not going to do that this time. This time I'm going to basically assume that this particle is just in the xy plane, and that this particle is in the x prime y prime plane, and I'm going to solve them and see what happens. So just to read the question, it states that a particle of mass 20 kilograms is held on a smooth plane which is inclined at an angle A to the horizontal, where tan A is 4/3. The particle is connected to another particle of mass 15 kilos by means of a light inextensible string passing over a smooth pulley at the top of the plane. Find the common acceleration, and also find out whether or not the 15 kilogram mass will rise or fall. So look, I've worked ahead a small bit. I've sketched the motion or drawn our free body diagram. I've drawn in the relevant forces. Notice as well, I have the x and y plane defined, I have the x prime y prime plane defined, and I've put in two sets of unit vectors. So for the x prime y prime plane, I'm using the I hat prime and the j hat prime vectors, and for the x y plane, I'm using the I hat and j hat unit vectors. I've defined gravity here as normal. I've put in the two tensional forces and the two weight vectors, and I also put in the normal vector. Alright, so I can get rid of this. I would suggest look at those videos 2, 4 and 6. So let's go ahead now and first of all look at the 15 kilogram mass. So we know of course from Newton's second law that the sum of the forces is equal to the mass times the acceleration vector. Alright, so let's apply that here. We're going to get, actually before I do that, we need to decide which direction we feel the system will accelerate. So I'm going to accelerate it in a negative a in the j hat direction here, and therefore it's going to go in an a I hat prime direction here. Alright, so let's just go ahead and do this. So I'm going to say it's t j hat minus 15 g j hat. That's going to be equal to the mass, which is 15 times negative a j hat. So what we can say is that t minus 15g is equal to negative 15a. I call that equation 1. Alright, that was pretty straightforward. Just put in the signs. We've already accounted for all the signs because we're using unit vectors here. Alright, I suppose if that's the case, let's say this is j hat and this is I hat prime. Alright, so one sec there now. Yeah, the j hat, that was correct actually. Alright, so now let's look at the 20 kilogram mass. If we look first of all at the x prime component, so we're talking about the I hat prime unit vector direction. So we're going to get the following. We're going to get the sum of the forces is t times I hat prime. It's going to be minus, and we need to start resolving the weight vector. So I probably really should have done that first. So in actual fact I'm going to just take a step back here, and we'll resolve the weight vector, something I did forget to do. So we need to find the two vectors which, when added together, create the vector, the weight vector here, and they must be parallel to the x prime y prime axes. So draw parallel to the y prime, parallel to the x prime, and they must be in these directions here and perpendicular. So the angle here was, this angle here is a, which means this angle here is also a, and we're told that the tangent of a is equal to 4/3. So look, I'll let you do it yourself, but you'll find of course that the sine is 4/5 and the cosine is 3/5. So this is going to turn out to be negative 20g times the cosine, and we said the cosine was 3/5. Alright, that's going to be in a j hat prime, and this is going to be negative 20g times 4/5 in an I hat prime direction. Alright, so let's just write this explicitly. The weight vector is going to be equal to negative 12g right, the other way around, excuse me. It's going to be negative 16g I hat prime, and it's going to be negative 12g j hat prime. Alright, so let's write that down. So W is equal to negative 16g in the I hat prime direction, and it's going to be negative 12g in the j hat prime direction. Alright, so pretty straightforward stuff. Now let's just finally go back to your Newton's second law and get the sum of the forces is equal to the mass times the acceleration. So we're going to get the following. In the I hat prime direction, you're going to get t times I hat prime minus, and we said it was 16g I hat prime is equal to the mass, which is 20, times the acceleration. So I said it's going in an a hat prime direction, so it's just going to be 20a I hat prime. Alright, so basically we're going to get the third equation is that t minus 16g is equal to 20 times a. Of course, if you do the sum of the forces in the j hat prime direction, you're just going to get the normal vector, which we don't need. So let's just solve these. Get my calculator. Alright, so we need to find out the tension and the acceleration. So let's just do the following. What if I take equation 1 or 2 from equation 1? We're going to get that t minus 15g is equal to negative 15a, and here you're going to get negative t positive 16g is equal to negative 20 times a. So it's going to be g is equal to negative 35a, and therefore a is equal to negative g over 35. Negative g over 35, what does that mean? Well, first of all, that is the magnitude of it is correct, as in the magnitude is equal to 0.28 meters per second squared. That's correct. Now, but what it does tell you is something else. Because this is a negative number. Now, if you remember, move back up here. When we talked about the acceleration, or when I talked about the acceleration, I already gave it a direction. I gave it a negative here and a positive here. So, what basically, because I'm getting a negative number, it means that the direction I thought the system would move at is actually incorrect, and in actual fact it's moving in a positive aj direction there, and it's moving in a negative a I hat prime direction here, like so. Alright, obviously if I'd gotten a positive number down here, then it would show that I had basically thought that, or I had worked out the correct directions of the acceleration vector. And because that isn't the case, well, then I was incorrect. So what does that mean? Well, it means that the 15 kilogram mass is going to rise. That's the first thing that means, alright? So, is there anything else we need to do about that? No, there isn't. So that's that. Thanks for watching. Please pass it on to your friends and subscribe to my channel.